Are old printers worth upgrading? Prusa Minis that like to kick parts away, and an update to my XL. All this and more, PrintFix Friday, episode 119. Let's get into it. Hey guys, welcome back to the channel, and if you're new here and you're struggling to get your prints running right, we are here to help. You can submit your fails to us by tagging us on the social medias, sliding into those DMs, or emailing us directly, youtube@3dmusketeers.com. But hey, if you don't mind, leave a like and get subscribed. It costs you nothing and helps the channel grow so that we can make more videos like this more often. We got a plethora of fails for you today, including an update to my Prusa XL and my continuing issues with bed adhesion, which I still think is something really stupid that I'm doing wrong, but I would love your help. So without further ado, let's get into fixing these fails. What improvements can be made here? We've got an interesting model, and it's not looking great. And normally I would provide some pretty useful advice. We're kind of working with older tech. This is a mostly stock DaVinci 1.0a using XYZ wear. That's their proprietary slicer, and for those that don't know DaVinci, or the XYZ 3D printing company, they are apparently still around, but they were famous for making a desktop printer that had pretty decent DRM controls, and then subsequently it was completely obliterated by the market of makers who cracked their encryption using an Arduino. So gotta love it. Whenever companies try to do something like this, especially years ago, makers did not allow it. The DaVinci line of printers, it didn't have the greatest sales numbers, and part of the reason they didn't succeed all that well is they attempted to use their own custom slicer. And the thing is, it doesn't give you the type of control that you might want. See, because what we're dealing with here, this is retraction, it's ramming, and it's also likely cooling issues. The cooling we can look at and say, all right, the ball there, that's going to be tough for any printer. So the fact that it even completed without knocking over, A+. But we definitely can see some cooling issues. We have some artifacts from the retractions itself, and down here, we can actually see areas where the model itself is not printing properly, or areas of under extrusion, if you will. And that under extrusion is important because it is likely some sort of a ramming problem that we have going on with the hot end. We could go and try to give advice on how to fix this, and things like adjusting your retraction settings in terms of the speed out and the speed in, specifically dealing with slowing down the speed that the filament goes back into the hot end if it isn't an all-metal hot end, and I'm not exactly certain if it is. And the worst part is I have one of these printers. It was a client's. I don't know if these things had all-metal hot ends. They might, but if they do, just make sure it's clean. If it isn't all-metal hot end and it has a Bowden tube in it for a PTFE liner, you might want to look at replacing that. But this printer's pretty old, and that age is my current concern. There's so much out there for very little money. Like, you can get a decent 3D printer for around 200 bucks. And if you're willing to deal with some of the security issues, Bambu's got some objectively affordable printers in their lineup if you're willing to expand your budget a little bit more. Now with the new Creality Ender 3 V3 SE and KE, I want to take a look at those. Do you guys want to see me take a look at those? I think it would be valuable to look at them compared to like the Solval SV06 and SV06 Plus, and look at some of the more affordable printer options on the market, because in a case like this, we could chase it down, chase it down, chase it down, chase it down. The thing is, this printer doesn't have good cooling. I actually don't think it has any part cooling at all. I think you actually had to add it as an auxiliary option, because that's what we did to the one that was brought to us. That's why I still have it. The customer never picked it up. And if you're watching this, take it, please. It's being used as an end table in my house. And I get that sometimes budgets might not allow to get a better printer, and that's totally fine. I'm not going to sit here and poo-poo someone because they can't afford a better printer. I know what that's like. It's a tough one because we can try, but we're slicer limited. At this point, we'd want to build a profile inside of something like Orca Slicer, Prusa Slicer, or even Cura. Honestly, anything is going to be better than XYZware. It is so old. It is abandoned. They don't update it for these old printers anymore. The least that we can do is look at slicing it in a new slicer. The thing is, I don't know what proprietary things XYZ has put into this printer, and I'm kind of worried about that. I want to help you. You're working with older tech. We can figure this out, but it's going to take some hardware hacking. I have some old motherboards laying around from printers. Like, I've got a ramps board here somewhere. It's what we use to test brand new 3D printers because I have never been able to kill a ramps. Oh, you hook it up reverse? It doesn't care. Oh, you accidentally fed it 4 times the voltage it was looking for? Yeah, no, it doesn't care. It doesn't care. I'd be happy to like send you a motherboard and try to help you unlock this machine and get it running. But ultimately, I believe that the best bet here might be to save up some cash, buy a new printer, and something like an Ender 3v3 SE or the Soval SV06. Those are going to be great machines that come at a sub $200 price class. While it's not cheap, for what these machines can do, it is miles beyond the amount of hours that it would take to make this printer good. And that's something that I think bears mention. And if you guys want me to talk about this in a larger video, let me know, because it might be a good option to talk about like this DIY or buy. Is it worth going the Ship of Theseus route where nothing is the same anymore and everything has been replaced? Or is it better to just save up all of that money that we would have put into upgrades and buy a new machine? I get the difference is it's like 20 bucks here and there versus $200 all at once. So love to know your thoughts on it. I think it would make for a cool video, but it might require us to take an old printer, upgrade the crap out of it, and then just compare it to a regular printer. So I don't know. Let me know your thoughts below, because I would like to kind of shop that one out to the comments and see what the comments think that we should do. I think it would be a lot of fun. But we do have some problems with this thing, and ultimately I think it's going to come down to that the hardware is limiting, the software is limiting, and ultimately the technology is limiting. Can we fix it? Yes, we can! With the software that you're using, no, we can't. We are not Bob the Builder. But if for some reason we can get this thing to work in newer slicers, I do believe we might be able to get at least marginally acceptable prints out of it. So I hope it works. Tearing infill and top layer. We've got a really ugly top layer here for this 3D print. Unfortunately, that's all that we have. We have a single photo. So we talked about this in the past. We'll card to the videos, you guys can take a look. But if you do want to get help with your prints, the best thing that you can do is give information. I don't know what printer it is, what material it is, what speed it is. I don't know anything. So I'm going to take some shots in the dark here. This is a kind of a term known as pillowing. And pillowing occurs when you don't have enough top layers. And in this particular case, when you are printing too cold. When you're printing too cold and too fast, the material will tend to shrink and split. It's very common to see this on the infill. If you can actually hear your printer printing the infill like it's running into other pieces of infill, turn up your temperature like 5 or 10 C and see if that helps it get rid of that noise. Often that is from the material shrinking, but also expanding. It's complicated. And the nozzle running into the infill as it's going across. In this particular case, the areas where we have like little humps, if you will, not my lovely lady lumps, but maybe yours. We're not putting enough top layers there to cover it. It looks like there might be maybe 2 or 3 total. This big mark here is likely from when it was doing that bridging process. A large area failed. The next layer that went over it still could not bridge, and it too failed. This is normally due to temperature. So if you can't go higher on temperature, or you're already pretty high on temperature, slow it down, because temperature and speed can be interchanged. If you need to run hotter, but you can't run any hotter, run slower. It's effectively the same thing. If you need to run cooler, but you can up your speed, well, run faster. Just be aware that things like acceleration and ringing and all that start to become a problem if you're not utilizing a printer with input shaping. In this particular case, I would increase my temperature 5 to 10 degrees centigrade. I would add a few more top layers, and I would make sure that the nozzle itself is clean. The brass or bronze brushes used in the firearms industry, they're used for like cleaning firearms. They're relatively long. They're about yay long, and they have soft bristles on one side and short, very stiff bristles on the other. Those are great for getting in there to clean a nozzle before a print without risking you getting hurt. Now, if you do buy those, don't buy the steel ones, because steel
is heavier than feathers.
Steel is harder than brass. But you know what is harder than steel? Diamonds. And I do want to thank Diamondback Nozzles for not technically sponsoring this video, but I'm going to give them the sponsorship anyways, because if it wasn't for Diamondback Nozzles, we would have never made it to Smurf on time. We had a bit of a challenge with the British rail system because they were on strike and they canceled every train out to Oxford, and we were stuck at the Reading train station for over 5 hours. And the absolute units that our Diamondback Nozzles drove all the way from Oxford to come pick us up, and the weary traveler that we had picked up that was also going to Oxford, a side quest. If you were, hi, Libby, if you're watching, I told you I would mention you in a video. Hi. They drove all the way from Oxford to come pick us up and take us to Oxford, and at the same time drop Libby off at her place. And yeah, thank you, Diamondback Nozzles, for that. I don't have a coupon code or anything, but they make damn fine nozzles, literally tipped in freaking diamonds. We'll link to them in the description down below. So if you do want to get a Diamondback nozzle, you can do that. And if you can even now get them for your freaking Revos if you want. There's a Diamondback Revo, which we are hoping to take a look at relatively soon. But yeah, thank you to Diamondback Nozzles. You guys are awesome. I greatly appreciate your willingness to come save Florida man, Florida woman, and Oxford lady who were all stuck. So, thanks. Anyways, moving on. Heat bed keeps shifting. This problem has only started in the past week. It keeps doing it after a certain height. I've tried going back to pre-input shaping settings. I've tried putting individual pieces, and it keeps happening. Send help. We got a Prusa Mini here that, I mean, honestly, all things considered, that's damn fine bridging. Like, I get the part is damaged, and I will get to fixing it, but it still looks pretty good, all things considered. I'm just saying. I'm just saying. So with the Mini, you have a couple of things you want to take a look at. One, it shouldn't be able to do that at all. There are 2 pins in the back of the printer, and your print bed has a little piece of it that sticks out. That should go in between those pins, and they should reasonably lock it in. Next, let's take a look at your Z-hop, if there is any Z-hop. The Z-hop is going to be important, because I think that's what's occurring here. When the printer is moving, the nozzle is catching something, and it's pulling it away. And from the looks of it, it is catching it on the, well, my right side of the print, although I guess it depends on which way you're looking at it, but printer right side of print, and that is causing it to shift everything sideways. I would also like to point out that it does not appear that it is actually shifting or skipping steps. So, kudos for that not happening. But more Z-hop should be able to solve this issue. I do notice that you should have support on this model, and you don't. And I don't know if that could be causing the issue. I can't really see the rest of the geometry, but certainly here, we need support. And here, we're drooping a little bit, so it could use support. If it is happening both pre and post input shaping, that at least lets us know that it's not an input shaping problem. The Mini is a decent printer. They're not exactly production ready. Like, they're just not. They're great kind of starter hobby machines if you have a little bit of an extra budget and, you know, you want to have the Prusa experience, if you will. But this one, I'm gonna guess is gonna be Z-hop related. I don't think it's gonna be belts, but it's not impossible for it to be belts. Prusa has an app where you're able to check these things, so you can try that. But if it's happening at the same place, I'm guessing, and it could be back here, that it is one of your overhangs is warping upwards, and as the printer is moving, it is knocking into that, causing the shift that you see. So if you don't want to use support material, you don't want to add any cooling to try to keep it from warping, let's look at adding Z-hop. You can put 2 millimeters of Z-hop in, who cares? Put 5. it doesn't matter because that Z-hop will help get the nozzle out of the way so it can move and then come back down. Now, the more Z-hop you add, the more likely it is to string, so just be aware of that, but it's not that big of a deal. I am noticing some stringing, and I'm wondering if you have combing turned on. Combing is where the printer will not attempt to move across perimeters. And if that's the case, combing might be running into things too. Because, like, there's no reason we should see strings on any of these areas of the printer, yet we do see it. So I would like to see if you have combing checked, because if you do, that could be it. And I think in Prusa, it's called avoid crossing perimeters. So, something to look into as well. Why are my prints slanting? We have an Elegoo Neptune 4 Max? It's a plus or a max. Oh, and by the way, thank you to all of you that correctly pointed out last week that I'm an idiot and forgot that there are fans on the back of these machines. I'm like, what? That's knocking into the frame. There was a loose screw on a printer. It really wasn't loose. It was just a screw that was protruding that was running into this back cooling fan. I don't have one of these printers, and it completely slipped my mind that they had those on there. So thank you to all of you that corrected me. That's what I love about PrintFixFriday, is that I'm not always right, and our comment section is freaking awesome, so kudos to you all. We have a multi-axis layer shift, which is pretty unique. It's not common that you see layer shifts in both X and Y, both at the same amount every single time. I am gonna go for two things here. Belts, pulleys. Check the belts, make sure they're tight, make sure they're not loose and skipping over things. Check the pulleys to make sure that they are tightened up against the motors and they are not wiggling at all. And if all else fails, hey, when in doubt, Z-hop it out, because that might help as well. This part does appear to be curling as well, but I'm not certain if that curling is due to the fact that it is shifted so dang much, or if that is something that actually occurs within the model. If it is something that occurs within the model, that might check out for that movement that we see, similar to the Prusa that we saw earlier, having the same issue where the hot end is dragging into the part, not letting it move appropriately and skipping steps along the way. Hope it helps. Next up, a fail from our Patreon and supporter Discord. If you do want to join it, it's the $10 tier and higher via any of the supporting links in that description down below. PayPal, YouTube channel members, Patreon, and coming soon to Printables and Things. At some point, I need to get that done. Oh gosh, I have a lot of things to do. Anyways, we've got a part here from Timothy H in our Patreon Discord. We have a Polymaker Polylite black PETG base with a white printed solid Jessie PETG going on top of it, and the Jessie doesn't look great. This is a classic case of temperature being a real issue when it comes to 3D printing. Just because something works for one color doesn't mean it's going to work for the other. And hilariously, at least for me, I find that Polymaker needs much more temperature than any of my printed solids. But in this particular case, that's not it. You gotta have more temperature, and that's why temp towers are so important to know. We actually did an entire video dedicated to temp towers. We'll card to it so you guys can take a look. In this case, when you do see it not connecting those lines like that, start cranking the temp. Go 10C, go 15C. You can always bring the temp back down. A little too much temp, you might see it popping and hissing a little bit if there's some moisture in it. You might see it start to string a little bit, but it will print more successfully than what we see here. When in doubt, add more temp in a case like this. This would eventually result in a pillowing result like we've seen earlier in the episode, but it's good to catch it early. Thankfully, not a ton is lost here, but sad day for the Prusa XL, because this is actually on an XL. I don't think this is the XL's fault, nor do I think the next one is the XL's fault. This is my Prusa XL, where I've talked about this a couple of times. I've been dealing with bed adhesion issues, and I still don't know why. I follow the directions that you guys had given me to wash it with dish soap, wash it with alcohol, and try again. And yes, this is very wet PETG. It is 5-year-old PETG. Still pretty great, by the way, that the part came out great. It was just really badly warped on the bottom like you see there. I am debating if it is ambient temperature and humidity related. This might be something that I want to dig a little bit more into, but I'm curious on what the next step might be. For me, my next step is to get like the 3000 grit sandpaper, some water and alcohol, and just very lightly wet sand that build plate to give some extra grip. The other thing is just wait for the smooth sheets to come back in stock, which I have a ton of experience with. I have very little experience with the satin sheets. I don't think this is the XL's fault, because, like, literally, I don't think it could be. I'm getting beautiful first layers. In this particular case, it's a PETG gray with a black PLA support material, and it is, oh, it's so great to just peel off the supports, and the bottom of the part looks perfect. It's wonderful. And this is a very organic structure. Everything on it printed perfectly, other than the warp, and I expected the strings. Like, that's just... I don't have a dryer in my garage yet, okay? And eventually, the XL is going to come in where it is going to replace the Fusion 3 above me and behind me. But for right now, once we're testing it, playing around with it, and using it in streams still, it's going to stay in the garage because it is very heavy, and your boy here don't want to be moving around a printer that's that heavy all the dang time. But I've had great experiences with my XL. I've seen a lot of people saying... You know, I've seen nothing but problems with these machines, and I've had great success other than the build plate, which I can't blame on the machine. I'm firmly certain that it is my fault. I just don't know what else to do. It has gotten relatively cold out there, well, for Florida, but it's the humidity that I think is the actual problem. So I'd love to know your guys' thoughts. I want to try out some more community-sourced ideas before I sand it, unless you guys all do say to sand it. And I would use Prusa support, but for me, it's actually more fun to ask the community before I go to Prusa support, because smoke them if you got them, if you will. But yeah, I've been really liking my XL. The tool changing has been perfect, back and forth between colors, between materials. I've seen no issues with alignment, and so that continues to push me down the path of the singular screw, which I'm still not a massive fan of. I do believe the tool heads should be mounted with more than just one screw, but that single screw needs to be torqued down way more than you think, and you need to wiggle everything to get that screw to really tighten so that it works properly. At least that's my personal take on it. Grain of salt, of course. Next up, a post from a Patreon supporter, Mustard Beef, who has a very upsetty spaghetti bamboo hot endy. That does not work. Oh well. We've got a leak from the hot end, and normally with a regular hot end, you would just need to tighten things because, oh, they're loose, and you can hot tighten it. And unfortunately, once this happens on a bamboo, that's it. You gotta go ahead and get a new hot end. Now, thankfully, Bamboo has made it relatively affordable, and you can go get hot ends for pretty cheap. But if you do want to play with one of the newest hot ends to come out for Bamboo from a third-party company that is actually first-party supported. Yes, Bamboo is officially supporting an aftermarket upgrade, which is super cool. They partnered with E3D to produce the Bamboo Obsidian High Flow nozzle, which is super cool, although it's technically an entire hot end. And we might have some that we're playing with, so stay tuned for that. It is very fast, and according to Sam from E3D, which we'll card to that interview, it just came out this past Wednesday, the day one of Smurf came out. It is from 18 cubic millimeters a second for the stock Bamboo hot end on PLA to 28 cubic millimeters a second. That's fast. And I think we will start to hit hardware limitations rather than actual hot end limitations, which is really freaking cool, if you ask me. But yeah, replacing is pretty much the only option here. But guys, I would love to get your help in finding more print fails. So if you are dealing with print fails, whether you think they're benign or you think they're insane, please submit them to us. We would love to get your assistance here, because while it is fun for me to go searching to find them, I always like it when our community says, hey, take a look at this and tell me how ridiculous this print fail is and how you might fix it. But anyways, guys, I do want to give a massive thank you to all of our channel member supporters whose names are listed right next to me at the $5 tier and higher. Thank you for what you do in making videos like these possible. And if you are looking for more Print Fix Friday, that'll be right below me, and right next to that will be our Smurf video coverage. That is all I have for you guys today. Stay safe out there. Don't forget to call your loved ones. It's the holiday season. Call your loved ones. And as always, keep making awesome. Don't forget to like and subscribe. Take care. This still looks pretty good, all things considered. I'm just saying. If I was saying any more, I'd be Super Saiyan. No, that's a bad joke.